Hello, doctor. My name is So Ling. My metric number is BB23010382. I will present the part 1, which is contrast appropriate graphs or charts to compare the relative frequency and cumulative relative frequency between the two key performance indicators. Before construct a graph, we have to create a table for the production cost and the profit margins to calculate the relative frequency and the cumulative relative frequency. For the relative frequency, we have to frequency divided by the total frequency to get the relative frequency for the each class. And then for the cumulative relative frequency, we have to total the relative frequency to get the each class for the cumulative relative frequency. As we can see here, we use histogram to perform relative frequency of production cost and profit margin. For the production cost, the histogram shows the tail on the right side of the histogram is longer than the left side, that indicating positive skew. For the profit margin, the histogram shows the tail on the left side of the histogram is longer than the right side, that indicating negative skew. For the next, we use ogive graph to perform cumulative relative frequency of production cost and profit margin. For these two graphs, we use upper limit of each class as the x-coordinate. As we can see here, both graphs is positive relationship as the production cost tends to be higher and also the profit margin tends to increase.
Hello doctor, my name is Doris Cheng and my matrix number is BB23010259. I'm gonna present about part 2, which is to calculate and compare measures of central location between the two key performance indicators. So here is the formulas of mean, median and mode. Mean is the average value of data set, while median is the middle value when the data is sorted in ascending order, and mode is the most frequently occurring value in the data set. For the mean of production cost is, I sum up all the value, which is 1,484.2, and I divided by the number of value, which is 30, and the last answer is 47.47. For the profit margin, also same with the production cost formula, and I got the sum of all value is 741.7 and divided by the number of value, which is 30, and I got the mean of profit margin is 24.72. Production cost has a higher average, which is 49.47 compared to profit margin, which is 24.72, suggesting that on average the production cost is more significant than the profit margin. Next is median. I got the median of production cost is 46.25. The median is the average of the 15 and 16 values, which is 43.7 and 48.8. So the median is 43.7 plus 48.8 divided by 2. So the median is 46.25 for the production cost. And for the profit margin, the median is the average of the 15 and 16 values, which is 25.2 and 25.5. So I plus the 25.2 and 25.5 and divided by 2. So I got the answer 25.35. The median for production cost, which is 46.25, is slightly lower than the mean, suggesting a somewhat skewed distribution. The median for profit margin is higher than the mean, which also suggests a slight skew but in the opposite direction compared to production cost. Next is mode. The mode for production cost is 36.2. Most frequent value in production cost is 36.2, which appeared twice in the data set. For the profit margin has 6 modes, which is 21.2, 22.1, 23.3, 26.3, 27.6, and 30, which all these numbers are appeared twice in the data set. Production cost has a single mode, which is 36.2, showing that this is the most common value in the data. For the profit margin has multiple modes, which is 21.2, 22.1, 23.3, 26.3, 27.6, and last one is 30, indicating several values appear with the same highest frequency, leading to a more varied distribution. Production cost tends to be higher on average than profit margin. With a more concentrated mode, profit margin is more dispersed, as reflected by its multimodal distribution and relatively closer mean and median values. For the conclusion, production cost tends to be higher on average than profit margin, with a more concentrated mode. Profit margin is more dispersed as reflected by its multimodal distribution and relatively closer mean and median values. That's all for my presentation. Thank you.
I'm Jobana Tsaipo and I will explain about the percentile and the construction of box plot. So for box plot, the important formula is this one, formula for percentile calculation. I will go through one by one. So L over here is the lower boundary of a class, and then K is the desired percentile such as 0.25, 0.50 and 0.75. And then next we have F, which is cumulative frequency, which is the data that we have in the earlier part, in part 1. Also F, frequency of class, also in the earlier part. And lastly we have H, which is class width, which means that in one class the distance to range between in one class. Once we understand this formula, we can easily calculate the percentile for production cost and then the profit margin. So we have this data. Minimum 11.8 is the end of the whiskers, and if you look at the production cost box plot, which is over here, and the maximum is 101.8, and then the quartile 1, 2 and 3. So quartile 1 means the start of the box, and then quartile 3 is the end of the box, and then quartile 2 is the median, is the red line over here. And then it's same thing for the profit margin. That's all from me.
My name is Clarissa Marinus, BB23110337. Would like to do a presentation about the 30 manufacturing companies in Malaysia for their production costs and profit margins using key measures of dispersions including the mean absolute deviation, variance, standard deviation, and coefficient of variation. These metrics provide valuable insights into how much each dataset varies and their overall consistency. So let's start with an overview. For the production cost, the mean absolute deviation is 21.65 million. The variance is 646.097. The standard deviation is 25.42 million and the coefficient of variation is 0.514. For the profit margin, the mean absolute deviation is 3.124, the variance is 14.468, the standard deviation is 3.8, and the coefficient of variation is 0.154. These numbers show clear differences in how production costs and profit margins behave in terms of variability. Now let's interpret these measures. For the mean absolute deviation, this represents the average deviation from the mean. The production cost has a mean absolute deviation of 21.65 million, significantly higher than the profit margin's 3.124. This suggests greater fluctuations in production costs. For the variance and standard deviation, both highlights the spread of data. The production cost has a variance of 646.097 and a standard deviation of 25.42 million, showing significant variability. In contrast, the profit margin's variance of 14.468 and standard deviation of 3.8 reflects much lower variability. For the coefficients of variation, this standardized variability by comparing it to the mean. For the production cost has a CV of 51.4%, indicating substantial variability relative to its average. For the profit margin, CV is only 15.4%, suggesting it is much more consistent and predictable. So for the comparison, production costs exhibit high variability across all metrics. This may indicate fluctuating resource prices, inefficiencies, or external factors impacting cost stability. For the profit margins, on the other hand, show much lower variability, suggesting consistent profitability relative to revenue. This is critical for maintaining stable business operations. So this means that addressing the variability in production costs could help stabilize operation and improve predictability. The stability of profit margins is a positive sign, but could still benefit from further cost optimization. In conclusion, production costs are more volatile, requiring focused management to reduce risk and inefficiencies. Profit margins are stable, which is positive reflections of operational success. Understanding these measures of dispersion is essential for identifying areas of improvement and maintaining financial health.
My name is Nizam, no matrix BB23111130. So today I would like to presenting about 30 manufacturing company in Malaysia for the both direction and the strength of the relationship. Based on the data, value of the covariance is negative 86.649. This is show that there is strong negative linear relationship between the two variants. Next, the value of the correlation is negative 0.89653. So this is show that they have a strong inverse relationship. This is mean that they tend to move in opposite direction as one increases and the other is decreases. So in summary, the negative covariance and strong negative correlation value show a significant inverse linear relationship between the two variables under consideration as one variable goes up and the other variable tend to go down in a consistent manner. Thank you.